All right, polar coordinates. Different stuff. We're in section 9, 6. We kind of skipped 8 altogether. It's about matrices. They don't ask us to cover it anymore. You're used to rectangular coordinates. When I say rectangular coordinates, you're used to an x value and a y value. Trigonometry allows us to be able to write things without x and y in rectangular form, but rather move to what we call polar form. And polar form gives you a radius value and an angle. So as I look at this diagram, or this grid, got 0, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, 2 pi. We've seen that before, right? So when it says plot and rename this point 4 different ways, what we're going to do is this. We're first going to learn how to plot these coordinates. Now, I know that when you're given a rectangular coordinate, you generally always do x first, then y. I would encourage you that when you get a polar coordinate, you first do the angle. So the angle of rotation is pi over 4. You don't have to draw that mark. I'm simply doing it to help you out so you can better see it and understand it. And then I move 3 units. 1, 2, 3 in that direction. So that point has a distance of 3 from the center, and it has a rotation of pi over 4 units from 0. And that's how I plot it. What do you think? What? I will do that in a second. Before we plot it or rewrite it in 4 different ways, I first want you to do this. Please try to plot the following. 4 4 pi over 3 and 5 negative 7 pi over 6. See if you could do your best to plot those two on your own right now, and then we'll get to some more difficult things. Okay, so 4 pi over 3 would place you right here. Did you get that? And then 5 negative 7 pi over 6 right there. Any questions on those two? Very good. Okay. Now we're going to do the trickiest part for people. This is where, by the way, I've never had a year in my, I think it's my 4th year teaching this now. I haven't had a year yet where people have left this feeling like, oh yeah, I got it. That's really good. Okay. The first part, just plotting points, fine, but renaming them, very confusing for a lot of people. So this is what you really want to try to pay attention to. 3 pi over 4, I'm going to rename it, but I'm going to use a negative angle. So what angle would I turn in this direction to get to that same spot? Negative 7 pi over 4. So the coordinate negative 7 pi over 4 would be my rotation. And then I would go 3 units in that direction. That's another way of naming that coordinate. Everybody okay with that? I could also start here. I could go around more than 360 degrees, couldn't I? What's pi over 4 past 2 pi? 9 pi over 4. So therefore, we have 9 pi over 4. You could, but that gets old after a while. I will show you something now that will be different to you. What I'm going to do is, instead of rotating pi over 4, I'm going to rotate to the other side of pi over 4. What's on the other side of pi over 4? 5 pi over 4. Now here's what you're allowed to do with polar coordinates. Is if you go 3 units, it would place you 1, 2, 3. Place you right here, correct? You can go negative 3 units, and that means you go directly on the other side. So negative 3, 5 pi over 4 is in the exact same position. Now, let's try again. What angle would give me a rotation that's in the opposite direction that would bring me to right there? Negative 3 pi over 4. And then would I go positive 3 units or negative 3? Negative 3 units. So you can see I've renamed it 4 different ways. These are all the exact same coordinate as 3 pi over 4. They all bring you to the exact same point. You are going to have to be able to, on the test, your first task will be to actually, plot the point, but then be able to rename it. What I want you to do right now is I want you to practice plotting these 4. I give you 4 different graphs, and then I want you to rename it 2 different ways. Make sure that one of the R values is positive when you rename it, and that one of the R values is negative when you rename it. Go ahead and give that a shot. Yes, on your test, I'll give you the 3 sheets of notes that you had on your previous test, and you will, again, create your own sheet as well, okay? When you get one of these answers, please come and place it up on the board so everybody else can check. Yeah, I can do 7th hour. By then I'm kind of on my last win. Just trying. Anyway, all right, here we go. So we want to convert from polar to rectangular, and we have r and theta. And from r and theta, we want to get x and y. Now, this might look confusing, but the fact is you just got done doing it in your last test. So I want to write an expression that involves x and r and theta. Now I'm going to say that the cosine of theta is equal to what? So if I want to solve for x, I'll multiply both sides by r. X equals r cosine. Does that look familiar? That was the horizontal component form of a vector. Then we have sine of theta is equal to y over r. Multiply both sides by r, and we get r sine of theta is equal to y. So if you want to find x and y, x is r cosine of theta, y is r sine of theta. Any clarification needed there? All right, now what if we want to go from rectangular to polar? Well, if I had x and y, how would you find r? Pythagoras, thank you. X squared plus y squared is r squared. So therefore, r is equal to the square root of x squared plus y squared. Now, on the last test, we did the same thing. We just called it a and b. Right? That's it. So you can see there's not a lot that's really new to this unit. We're just kind of using some different terminology. You also know that the tangent of theta is equal to b divided, I'm sorry, instead of b over a, I have 5 over x. Now again, for your test, you get the 3 pieces of notes that I gave to you, but then you also get to put together your own sheet. I would think that these would be important things to put on your sheet. All right, so convert this to rectangular form. It's currently in polar form. So what I do is I take x is equal to r cosine of theta. What is r? Times the cosine of 2 pi over 3. Is there an exact value for the cosine of 2 pi over 3? What is it? So the x value is -2. What's the sine of 2 pi over 3? Very good. And so we get 2 roots of 3. So our coordinate is -2, comma, 2 roots of 3. Nothing different than last time, right? Just a different application. Polar form to rectangular form. Before we were doing complex form to trigonometric form, back and forth. Now we are given rectangular coordinates and we want to find the polar coordinates. So I have to find r. Well, according to your notes up above, you said that r was equal to the square root of x squared plus y squared. What is x squared? What's y squared? Square root of 18 or 3 roots of 2. And then we set up the tangent of theta is equal to y divided by x. Which quadrants is tangent negative in? Second and fourth. Very good. All students take calculus. So all trig functions are positive in the first quadrant. Sine is positive in the second. Tangent and cosine are therefore negative. Tangent's positive in the third. Sine and cosine are negative in the third. Cosine's positive in the fourth. Tangent and sine are negative in the fourth. Yep. So sine is y, so y is positive up here, but it's negative down there. That's how I remember it. I never think of that in my life. If I think of cosine, I think x is positive, and so cosine is positive there, it's negative here. And I think tangent is y over x, so positive over positive, positive, negative over negative, positive, and here they would be opposite. That's how I think of it. This other y over x, yeah. That's how I think of it, yep. I don't know who made this up. It's just... Okay, so we got to find theta. Which quadrant are you in? The second or the fourth quadrant? You're in the fourth quadrant because you're over 3 and you're down 3, right? And so when you tangent inverse 1, you get pi over 4, 45 degrees. So this angle there is going to be 7 pi over 4. So I have 3 roots of 2 is my r, and 7 pi over 4 is my theta. I tangent inverse 1, and I get pi over 4. I know it's in the fourth quadrant, so I go pi over 4 units this way. or a turn of pi over 4, which brings me to 7 pi over 4 question. If you're finding an angle, you should tangent inverse or sine inverse. You do that when you're finding an angle. We did not know what this angle was, right? This is our variable. So you want to solve for theta. In order to get rid of the tangent, you have to tangent inverse both sides. Well, here you had cosine of 2 pi over 3. There you didn't. Your variable wasn't right here, was it? But you actually take the cosine of 2 pi over 3. If you're trying to find the angle, inverse. If you're not, just operate as normal. Okay? Because we are over 3 and down 3. Over 3, down 3. Assignment.